Whenever you're ready, maybe you can ask her. We are in live.
Show me the title again of the talk. Morning, everyone. Take your seats and stop the chatting. Also the teachers. Also the professor. I'm so pleased to do that because I'm not a teacher and I never get to do that. It's really marvelous. I like that. Maybe I will become a teacher once. Anyway, it's my big pleasure to introduce Katrin Holden today from Pädagogische Hochschule Kärnten, Klagenfurt. And we are very eager to hear about her and about her approaches to introduce MINT didactics and STEAM didactics into schools. Please welcome Katrin.
Yeah, and I do
Yes.
but no. Just a moment. And to look at this. Okay, here it is, but I have to present this. But how can I do that? Oh, very good.
Yeah.
This one, but I need a video clip. No, that's okay. This one, yeah.
Sorry, that's my problem.
Okay. Yeah, thank you very much. Okay. Yeah, thank you very much for the invitation and for the possibility to present the projects I did in relating to 3D printing. To be honest, I'm not an expert in 3D printing, but I like to use technologies in my teaching at university, Viktor Frankl University of Teacher Education, and I like to try things out with technology at school sometimes, especially the 3D printing. And when I asked Eva about the audience, she told me that you would be people who are especially interested in geometrics. And so I thought about the learning environment shadow images. I developed this learning environment together with my former colleague, Amelie Vogler, and she writes her PhD thesis and uses the data of this of testing this learning environment. And I have to thank her that I may show, give you an insight into this project. Amelie is a teacher at primary school, and she asked me to support her about the physics stuff because I studied mathematics and physics at the University of Siegen in Germany. And so we developed it together and had lots of ideas. And yes, I would like to give you an insight. But before, I can't go, here. Okay. I would like to tell you something about my assumptions of mathematics and of mathematics in school. And I shortly want to talk about digital literacy because I talk about it with my teacher students in the lectures. And I think it's worth to talk about it and to think about it. And then we get the insight into the learning environment and a summary and a prospect. And first, I want to ask you, because unfortunately, we missed to ask our kids what they think about shadows. And now I would like to ask you what you think about shadows. No, not shadows. Sorry, it's the first question. What do you think about experiments in mathematics lessons? So that's the right question. And I would like to know if math is a natural science, in your opinion. What do you think? And you can participate. Join Slido with this QR code. And it would be great if you only use a buzzword so that we can have a word cloud on here. Okay, we have 16 participants, so I think we can, oh, 2 are typing, okay. Yeah, but I think we have yeah, a good word cloud, and you see many of you said yes, and some people said not necessary. That is what you think, and now we have a look at what the experts think or say. There we have Burchard and Struve, and they said if we look at the researching mathematician, the difference between him and his scientific colleagues become increasingly blurred. And maybe you know Schoenfeld, he was a problem solver, and he said logical reasoning in particular, but also intuition and empirical testing were part of a mathematician's toolkit. And we can look at what Grigorich, Ratz, and Turner said. They worked on beliefs of mathematics, and they said logical deductive reasoning in a systematic and static science is indispensable for the verification of hypotheses, but does not primarily contribute to the generation of hypotheses. For a cognitive point of view, mathematics is not less than experimental inductive science, which essentially makes use of conjectures as well as plausible and analog reasoning. So here we can see the difference between the mathematics as science statically and doing mathematics as a process. It's different, and doing mathematics is it's close to the natural science. And when we look at the schools in school books in Germany and as well in Austria, you can see that teaching mathematics is characterized by an action-oriented and example-based approach. I don't know how it is in the other countries, but I think in many countries you will have hands-on material-based learning in mathematics. And even de Hebecker, but also my former colleague Felicitas Pielsticker and Struve said that in mathematics lessons, concepts and content are consciously presented as real-life phenomena using empirical objects. We are dealing with these empirical objects, and the knowledge is bound at these empirical objects. And from an education and policy perspective, real-life applications from nature, from society, and culture must be integrated into the teaching of mathematics. Winter, he was a German mathematics educator, said this, but it's also in the curricula. And if you think about STEAM didactics, it's really necessary. Thank you. And I think, and also Beckmann, this requires a multi-perspective view and treatment of phenomena in terms of a cross-curricular approach. And I found in my PhD thesis, where I worked with teacher students, that enabling learners to develop sustainable knowledge in subject lessons using non-subject specific context requires additional context-specific content knowledge and pedagogical content knowledge on the part of the teacher. And how can we enable the teachers to get this not subject specific, not mathematical specific content knowledge? That's the question I want to solve. Now we can have a look at the digital literacy, and I do it with my teacher students. I think you all know this. I talked about content knowledge and pedagogical content knowledge, and it is from Schulman, this framework, and Kohler and Mishra adapted this framework and made the technological knowledge within these two bubbles we have the content knowledge, the pedagogical knowledge, the PK, the CK. In between, we have the PCK, pedagogical content knowledge. This we know from Schulman, and there is a technological knowledge, TK, and we have this and this, where is technological content knowledge and technological pedagogical knowledge. It's more that we have to think about in teacher education when dealing with technology. And I participated at the project DigiMath for Edu at my time in Siegen, and we worked with schools, with different schools from primary school to secondary school, and we treated the math teachers to use technology, and we gave them the technology, and we gave them assistants. There was in every school there was at least one person, but sometimes two persons from the university teacher students who could use this technology, who had many ideas to use this technology in mathematics lesson. And so the teacher could concentrate on doing mathematics with the technology, and the teacher students cared about the working correct. And this is a thing that Eva mentioned yesterday. You need a person who you can ask if you have to get help. And in this project, we developed another framework. It's the MPC. It's a little bit different to the TPEC model because Dilling et al. Looked at the bubble media, content and pedagogy, and it's media, not technology, and they divide between media and digital media. And when we have a close look at this, we have this bubble media and the digital media, and here we have digital pedagogical knowledge, digital content knowledge, and digital pedagogical content knowledge. It's another way of looking at the knowledge in using technologies for teachers. Here in Austria, there is another framework. They have the DigiComp at school, and it's on the level digital competency, digital literacy at level A. And they made it more great, this framework, and made the DigiComp P, digital literacy for pedagogues. And you begin at school here, and when you are at university, the pre-service teacher training is here about B, C, D, E, F, maybe G. And if you are a professional teacher at school, you can reach the H. This is another framework, and it's defined what the different levels are in this framework. I don't know if you have such a framework in other countries. In Germany, we have some, but it's more complicated than this. This is a little bit compact. It's okay. And what I ask my students is, what means digital? And I think Koch has a definition which is usable in lessons. She says computer science defines digital denotes a finite, it as limited set of discrete characters of the same type. And she needs she shows a metaphor, the sundial, and she says while the sun produces corresponding analog shadows in a continuous movement in the sky, a clock face over which the shadow runs sets corresponding discrete digital numerical values. This is here for the time. And so digital and analog are often linked, as in the sundial. And I think this metaphor is quite good. I like it. And then I asked my students, what is digital media? And the literature says media conveys science as speech, sounds, letters, images between subjects and or objects with the aim of disseminating information. And media are understood as intermediaries through which potential signs are transmitted, stored, reproduced, arranged, or processed in communicative context with technical support and presented in pictorial or symbolic form. And then it's very interesting. I asked my teacher students who are not familiar with technology and who are not teaching at school, what do you think? What is your position? Would you use digital media or technology in class very often or not so often? And what do you think about digital media in the classroom? Do you think it's not good in the class, or do you think, oh great, I think it's necessary? And then they make a dot, and we have such a dot cloud, and then we can see where they are. And often some students are here and some students are here, and I say it's good if you are in the middle. Here it's euphoria, and here you have bias against digital media. And if you are in the middle, you are a critical optimist. It's okay if you are here in this area. Also, I would like if you were in this area. And what I also like is the pencil metaphor. Here you can see different teacher types who are using or not using digital media. And I only want to focus on the leaders. These people are the first to take on the technology, the early adapters who usually document and enthusiastically share what they have tried, what's and all. And I think you are the leaders here in this audience. And at the other end, we have the erasures. Maybe you have some colleagues at school or at university. The erasures are people endeavor to undo much, if not all, of the work done by the leaders. It's okay if we know we have an erasure in our colleague. It's okay to handle it. And what I like, but it's working only in English, is the would. These people would use the technology if some would give them the gear, set it up, train them, and keep it running. All they need is help from some sharp person, and they would be doing it too. And I think we have to be this person who is helping these colleagues. Then there are different frameworks for using technology. I think you all know the SAMRO model by Ruben Puentedura. He says you can use technology as a substitution, as an augmentation, or when you transform it, as a modification or a redefinition of non-digital media. And I found the SAMRO swimming pool, which Stevens developed. And I'm not sure, I think we can't look at the video, but if you have time, you can look the video. It's only 3 minutes. And I like it. She defines what she thinks about. And she says it's not necessary to be in the redefinition. You have to swim laps. And then, you can work it. And she also says everyone can use support on every stage here. So I like it. Then we have the 21st century skills, but if I yesterday told about, I think we don't need it. And the 4C, let us come to the shadow images. I would like to give you a short insight into the learning environment. And now you can think about what yeah, what you know about shadows and how does a shadow occur in your opinion. Please try to give a short answer though, that we can see the answers here. Yeah, great. Thank you very much for participating. Many of you said we need light, and it's not clear that the kids know that you need light. The kids sometimes think the object is throwing the shadow on the wall, and it's a preconcept, and we have to know about the preconceptions of the kids. And so I would prefer to ask them what they think about what a shadow is and how a shadow occurs before doing this this intervention with shadow images. And what we did was to give the kids this shadow image, but not this shadow image directly. We had this experiment. I can't go back, sorry. But you remember the photograph of the object and the screen. We showed it, but we hide the object. They didn't know how the object looked like, and then they had the shadow on the screen, and after that we gave them this shadow image, and we asked, you see a picture of a shadow, what does a body or a building look like that could cause this shadow? Take a guess. Because we want to do inquiry-based learning, so they have to formulate a guess and describe it as accurately as they can. And then we went to Tinkercad, and the kids had to recreate the corresponding body or building. And then we said, please think together about how you can check that your bodies or buildings really do cast a shadow that looks like the shadow image. Describe a possible procedure. And after that, they, we printed the bodies or the buildings out and with a 3D printer, and the kids, may do experiments with their bodies. And then we gave them more of these shadow images and asked what might bodies or buildings look like, and did the same. They were able to build them in Tinkercad, and then we said create a new body or building in Tinkercad and think about what the shadow might look like. Draw the shadow image before checking it. It was another discovery mission, and they were really creative and made incredible buildings. And we printed them out if it were possible to print them out, and they discovered the shadow images. And what they discovered, I show you later. At first, I want shortly tell you how Amelie came up with this idea to make the learning environment shadow images. She looked at a German textbook, and I think in Austria you can see similar things in the textbooks. You have to sign the image, to draw the image from the right side, from the left side, from the front, or from the back. And it's like this. And you have a hint here at the book. It says, I have to look at the building from exactly the direction that it says, so I can draw it correctly. And the kids looked like exactly at this direction and try to draw. And what happened was that, what can I show you? No, I can't see the right image here. They try to draw it, in a perspective way like this, and not the image of it. And it's really hard for the kids. And Bauersfeld said, illustration is often based on false premises because it purports to construct causality where only an assumption of the cognizant mind is present. And you can solve this if you are, if you have a cognizant mind, but the children don't. And we, the teacher, think they could do, but they can't in this way. And so she thought about doing it in another way. And then she found a material, but Hebecker said school geometry is related to recognition and description of structures in our environment, and thus to three-dimensional visual space. And in my PhD thesis, I found this reality is subject to certain physical laws, which is why it is worth making at least a subject-related transition to physics for the didactic preparation of corresponding mathematical phenomena. And then she found a material of Markus Helmerich and Katja Lengning. They said to visualize the image or the projection, it helps to imagine it as a shadow cast by a body on a projection surface behind the body. And this material looks like this. You see the shadow box here, and the kids have to explore the shadows with a lamp in this shadow box, and they get the front side, the front view, the side view, and so on. And so Amelie made it in her lesson. And she found that it's not that simple. She tried to do it with this building, but the shadow is not like it had to be. It should be like this, but it's not. It's very hard to become it like this. It's nearly not possible. And then we thought about why is it? And here you have the mathematical explanation, you know it, and that's the assumption of the textbook. The textbook says that, or thinks that this is a parallel projection, but it is not. If you look at it closer, you can find that we have a central projection. And that's why you can see some difference between the shape which is nearer to the screen or which is nearer to the lamp. And I made it with GeoGebra. It's very useful for this. It's not that in classroom realities, and that's a difference. And the kids noticed this difference. They did experiments, and then they came up with the idea to use such a line to mark it. Very, yeah, it's fantastic which ideas the kids have. And then we asked them to explain why it is like it is, and they signed these drawings. And if you look at our drawing, it's nearly the same. You have the light source and the textbook thinks that the light source can transmit parallel light, but it's not. It's the green line and the green shadow here at the screen. But in realities and classroom, you have the central projection, and you will get this black shadow on the screen. It's a little bit bigger. And yeah, I like what the kids did with this. So summary and prospect. Amelie and I, we think that we enable learners to experience the content area of bodies and their two-dimensional representations with this learning environment shadow images. And they get an open-ended exploration of the physical phenomenon of shadow formation. We can stimulate conceptual development because it's different between shadow and shadow image. It's not the same, only to mention the physical concepts. Learners explore the geometric properties of the two-dimensional shadow image of a body and the relationships between the position of the body in relation to the screen or the position of the light source in relation to the body and the shape of the shadow actually cast. And if we look at the teacher side, from a teacher's perspective, we can enable a meaningful development of knowledge that goes beyond the boundaries of disciplinary knowledge, as we could do in normal mathematics lesson. We can take the physical context of the learning situation seriously. It's hard to do it as a mathematics teacher, but I think it's necessary to take it seriously. We recognize which physical ideas or preconceptions learners have, and we can pay particular attention to the phases of knowledge, explanation, and interaction with the learners. It as sensitively direct negotiation process into the right channels. And then we ask, how can holistic, individualized learning succeed? And Amelie and I think as the score of interdisciplinary teaching, holistic individualized learning in the sense of the learner's grasping of a context must be seen as an ideal that can only be achieved through a multi-perspective view of the learning object and or the method. It depends on the part of the teacher when dealing with the teaching topic. In this context, a multi-perspective view of the learning object and or the method of dealing with the teaching topic must be understood as the inclusion of different disciplines and discipline-specific pedagogy. And we wrote a paper, but unfortunately it is in German and it's not published yet, but I think it will come in May. And what I'm doing now is to participate at the Schulversuch Mittelschulen in Austria. There are 57 middle schools participating, and they have the subject STEM at their schools, and they have at least two lessons in the week STEM, additionally to the subjects mathematics and physics, biology, and so on. And yeah, I'm glad that I may participate in this project. I'm at the Pädagogische Hochschule Kärnten since November, and the project started last year, and it will, I think it will last till 2027 or 28. If you are in Austria and you want to participate, please don't hesitate to contact us, and so you can become a middle school, a MINT middle school if you want. Yeah, and I can observe the kids there and make project-based learning and inquiry-based learning and try to understand how the kids think and what we can do to support the teachers who have to teach MINT or STEM in English, MINT in German, and they didn't study it. Maybe there's a teacher who studied English and maybe arts, and he has to or she has to teach STEM at the middle school. And I would like to know how we can support such teachers. Yeah, and let us explore more of the light and maybe the shade of 3D printing. I'm interested in hearing more of your projects. And thank you very much again for being here.
Maybe do we have questions, or are you in charge of that?
I'm in charge of that now. Questions, please. If you're not having one, I have one. I was wondering, you were showing the picture of the pencil and the different types of teachers. And there's this large group of teachers that would do something if they just knew how. But there's also this handle of teachers that go to all courses and whatnot and still don't do anything. What's with those?
I don't know. I found this metaphor and I thought, yes, it could be that in every school there are some teachers in every of these categories, but I don't know how to handle. Sorry, I would like to know how to handle that.
Yeah, that's something that my sister told me. She told me she now has to go to courses about digital literacy, but she's not interested.
Oh, okay.
And she must, because there has to go someone from her school, and she's the one that knows the most about the topic. But she's not interested, not even doing it with her students, because they're primary school kids. And what she's learning there is not appropriate for this age. So perhaps we also have to be very careful with what we do in courses, whether it's useful for teachers or not.
Yeah.
So perhaps that could also be a reason those teachers just not attending to correct courses.
And I think, but it's not empirically tested, it's my own opinion, that only if the teacher and also at the university teachers, only when they burning for the stuff they are doing, it works.
Perhaps.
Otherwise not.
Perhaps. That's probably true. So any more questions? Okay, then thank you very, very much. It was incredible, like eye-opening, interesting, because I thought it was so clear in the textbook, but it's not clear to the kids. And then the experiment was so clear, but of course, silly me, it can't work. Yeah, thank you very much. It was very eye-opening.
Now, we had a coffee break, and then we are moving together to the workshops. So instead of you going there, we just meet here and go all together. And I think that's, oh no, we had one more thing. You wanted to share something? Yeah, please. Just one more second. I think no, I'm sure they haven't. Let me share the screen here.
So has anyone heard of the Crochet Coral Reef project? No. Who knows what crochet is? Yeah, crochet, not knitting. Crochet is just one hook and yarn, and it is the only manufacturing process that they have not managed to mechanize. It has to be done by hand because the movements are too complicated. Well, some time ago, 2 Australian mathematicians, scientists were very concerned about the state of coral reefs. With global warming, the coral reefs are dying, so a part of our ecosystem is perishing. And so they developed this idea, which is very mathematical. It's hyperbolic geometry, that you can crochet models of reefs. So it's science communication to everyone. You get a lot of participants, particularly women. So it's gender good in that sense. And you can see that you've got the dying reef that's in white and the others are vibrant colors. So they've taken these all around the world and they involve local people, and there is one in Linz. And I was so pleased to hear about it. I thought it finished on April the 1st, but it doesn't. It goes on till July. But so Australia has a coral reef. No sea, but a coral reef. They've taken national colours as well, apparently, and national fabric designs to make these coral. And it's inspired both by mathematics and climate change. So some images. But as an extra, there are some 3D printed exhibits as well by an American guy called David Bachman or something like that. Okay, so we're going to go.
We decided we would just ask you to come afterwards after the talks with us, looking at that, because it's nearby the restaurant where we will have dinner.
It's the same tram stop, I think,
Yes,
isn't it?
yes.
One direction is the Schloss Museum.
Yeah.
Is that right?
Yeah, I think so.
Yeah, and the other is the restaurant.
Well, don't ask me, I'm not from Linz.
On the map,
Anyway,
on Google.
we thought we would invite you to join us.
Yeah.
We wanted to look at that. We are really interested in that, and we would be happy to go with you.
Yep.
Let's go there.
So we'll be here at 4 o'clock, and we can catch the tram together. Yeah. Okay. Right. Thank you. Advert over.
Thank you.
Anybody wants to talk to me about crochet and coral reefs? I will.
Cool. So coffee break, and then we meet here in 15 minutes, so we can go together with to the workshops. Thank you very much.
I'm always in front of the camera.
Don't worry.
Learn where it is.